Why is Elon Musk suddenly pushing thousands of Starlink satellites down to a lower altitude? Could this be a quiet admission that the space junk crisis is getting out of control? We already have fragments in orbit and near-miss encounters happening in margins so small they barely sound real. That's a red alert. Low Earth orbit is getting crowded enough to feel unmanageable. And when you force thousands of satellites to descend around the same time, are you cleaning up or increasing the odds of a chain reaction no one can stop? The scariest part isn't a machine failing, it's human overconfidence. If we manage this poorly, we could trap ourselves inside an orbital junkyard and lose critical services from satellite internet to emergency communications and science. Stay to the end because I'll show you what this move fixes, what it can't, and why a single bad collision could rewrite the rules of space for decades. And it's happening in 2026, not later on. So let's start with the simplest question: why now? Starlink is the world's largest satellite internet network, with nearly 10,000 active satellites serving consumers, businesses, and governments. But the more satellites you pack into the sky, the more congested it gets. And in congestion, collision risk doesn't rise gently, it can rise fast. That's why experts warn that LEO, low Earth orbit, is turning into a highway with no traffic lights. Satellites move at tens of thousands of kilometers per hour. A tiny deviation, a brief loss of control, or a bad prediction window can become a collision that creates thousands of debris fragments. Those fragments can hit other satellites, triggering the nightmare scenario. The Kessler Syndrome is a cascading chain reaction where debris becomes so dense that certain orbital bands turn extremely risky or effectively unusable. And this isn't just theory. There have been reports that a viewing window component associated with China's Tiangong space station showed small cracks suspected to be caused by tiny debris impacts. Some researchers also track a crash clock, an indicator estimating how close orbital density might be to conditions that make a major collision more likely. Every additional launch, in that framing, pushes the clock forward. Starlink says it's responding by reducing risk through an orbital reconfiguration. The plan, satellites currently around 550 kilometers, will be gradually lowered to roughly 480 kilometers across 2026, according to Michael Nichols, Starlink's VP of Engineering. But why 480 kilometers? Why not lower or higher? The answer starts with one word: density. Nichols argues that below 500 kilometers, there are fewer debris fragments and fewer planned mega constellations concentrated in that band, so overall collision probability drops. There's also a technical factor that sounds dry but matters: solar minimum. As the sun becomes less active, the upper atmosphere thins. Thinner air means less drag, and less drag means a failed satellite can stay up longer, sometimes for years, drifting as a hazard. Nichols says lowering the orbit can reduce ballistic decay time by more than 80% during solar minimum. Instead of a dead satellite lingering for 4 years or more, it might re-enter in months. In plain terms, fewer zombie satellites hang around long enough to cause secondary collisions. So, what pushed Starlink to act? Piece 2, a debris incident. In late 2025, Starlink acknowledged a satellite anomaly around 418 kilometers that produced a small amount of debris, lost contact, and dropped several kilometers quickly, suggesting a serious onboard failure. The company didn't publish full details, but the takeaway is obvious. Even a sophisticated constellation can still suffer rare accidents, and each accident leaves a footprint in orbit. The Register described the event more starkly. The satellite may have vented propellant, lost stability, started tumbling, and shed fragments. You don't have to be a spacecraft engineer to understand the danger. An uncontrolled object on a crowded orbital highway is a nightmare. Piece 3, orbit is getting crowded, and the satellite race is accelerating. It's not just Starlink. Amazon's Project Kuiper targets 3,000 plus satellites. China has been widely reported as planning constellations that could total 10,000 plus satellites for competing services. Each project can be defended alone, but together they raise a bigger question. Are we turning LEO into a giant parking lot with no real management system? And as congestion rises, near misses become less surprising. SpaceX has said a Chinese satellite passed extremely close to a Starlink satellite, reportedly within about 200 meters. In space, 200 meters sounds like a distance until you remember orbital speed. At those velocities, that separation is the equivalent of a blink. Whether or not it caused a loss, it's a warning. So how does Starlink's altitude shift happen in practice? Reports suggest the migration could involve around 4,400 satellites, nearly half of Starlink's active fleet. Starlink says it's coordinating with other operators, regulators, and the US Space Command. That sounds reassuring, but it also raises an uncomfortable question. Is this truly safety for everyone or optimization for Starlink framed as safety? To see the motive, look at three pressures pulling at once. Technical pressure. Lowering altitude can help. Failed satellites re-enter faster, debris doesn't linger as long, and below 500 kilometers may be less congested right now. Commercial pressure. Starlink is a business. One major collision could trigger stricter regulation, higher compliance costs, or service disruption. Risk reduction protects the business model. Political and social pressure. Groups like PERG have urged the FCC to pause or slow LEO launches until space pollution is better managed. Meanwhile, Musk has dismissed fears about too many satellites as overblown. China has also reportedly raised concerns through international channels, calling for stronger enforcement around commercial space activity. So yes, dropping altitude by about 70 kilometers sounds technical, but it sits at the intersection of engineering, economics, regulation, and global power. Will lowering Starlink's orbit save the sky? Honest answer, it helps, but it's not magic. It can speed up re-entry for failed satellites during solar minimum and may reduce collision probability in the near term. But satellite numbers are still rising. Kuiper will keep launching, other constellations will keep launching, and with tens of thousands of objects circling Earth, you need more than a lower orbit. You need real space traffic management, shared data standards, clear avoidance rules, accountability for debris, and enforcement with teeth. Here's the key message. LEO is no longer an infinite frontier. It's a limited resource. And if it gets jammed, everyone pays for satellite internet, emergency response, weather monitoring, research, and national security. So what can 70 kilometers really change? It can change how quickly orbit self-cleans after failures, shift collision probabilities in the statistics, and force the world to see the satellite boom as a governance problem, not just a tech story. And one final question to leave you with. If a major collision creates thousands of debris fragments across orbit, who is responsible and what law is strong enough to force cleanup and prevent the next one? Like the video and subscribe so you don't miss what comes next.